Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2, Section 1 for the subject CSCI 2300, Data Structure and Algorithm 1. This is my group member. This is the topic that we're going to present. This is a linked list using pointers. This is the task distribution. The basic operation for the list are insertion and deletion. For the introduction, a list, also known as abstract data type, is a sequence of 0 or more elements. The basic operation is make empty, print list, insert, remove, find khash, find, and find. List can be implementation using the array base and pointer base. For the array base, the basic operation are searching, inserting, and deletion. While for the pointer base, it is known as a series of connected nodes where each node contain at least one piece of data and the pointer to the next list. The variation are singly linked list, doubly linked list, and circular linked list.
Hi, my name is Nurul Hanis. I'll be presenting the implementation of single linked list using C++. These are the functions of the operation that will be explained later. Let me start with the creation of linked list. First of all, we need struct to hold nodes with data and pointer to hold address of the next node. We make a temporary nodes null since there is no valid value yet. Is the insertion of data. If the head of the first node is not null, then we have a linked list. The address of the head will be placed in the next field of the new node to connect new node to the first node, which is head. Deletion of data. In linked list, we can delete a specific node. We pass the address of the previous node to the next node and then the temporary node to the next. This way, the current node is removed from the linked list and link is established between its previous and next node. Therefore, it will be deleted successfully. Lastly, display function. This function makes a temporary node pass an address past the head of the node to it. To print all of the nodes on the screen, we need a loop which runs as many times as nodes exist. If temporary node becomes equal to null, then the loop will be terminated. Now let's take a look on the output of the compiled codes. This is the output of the compiled codes. As we can see, we inserted all of the data. And we also deleted the fourth data in the list, and we also displayed the linked list. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatina Jomiti Ramli and I will be presenting on theory of explanation of single linked list. So firstly is delete. So this is how the data will be look like, and for example if we want to delete C, so this as we can see here, B is pointed to C, and so if we want to delete the C, the B will be pointed to D, which is the data that have been pointed by C. So after that, the C will be deleted from the list, and after that, the list will be like this. And for insert, for single linked list, for example, if we want to enter the data at the place of C, the data will be pointed to C first, and after that, B who pointed to C will be pointed to X, which is the data that will be inserted, and after that, the list will be like this, which is the X will be pointed to C and B will be pointed to X. As for find, the data will be named as which is the first data will be pointed as null, and the next data will be pointed as 1, 2, 3, and 4.
Hi, Assalamualaikum. My name is Anis Asila binti Osman, and I will explain the coding in W linked list by using C++ for insertion and deletion. The insertion are same as singly linked list represented by sysHanis. In W linked list, we also use struct to hold the node to hold nodes with data. And first, in insert node at the front, we will allocate memory for the new node. Second, create a new node and insert the number in the data field of the new node. The previous pointer in new node points to null as it is entered at the beginning, and the next pointer points to the head. And lastly, if the head is not null, then previous pointer of head points to the new node. And finally, the head is the new node. Insert node at the end. Coding for insert node at the end are same as the insert node at the front, and the differences is only we insert node at the end of it at the tail. Insert node after given node, and first thing first, we have to check if previous node is null or not. If it's null, it will return from the function because any new node cannot be added before a null. And the following step will be same as the previous insertion, which is allocate memory for new node, assign data to new node, and set next of new node to next previous node, set next of previous node to new node. And if the previous node of the new node is not null, then set the next pointer of this previous node as new node. For deletion, first thing first, we have to write a function to insert the node, then initialize the W linked list with some data, take a node to delete, and write a function to delete the node. And before that, we have to consider the following three cases while deleting the node. And the three cases is, first, if the node is head node, then move the head to the next node. Second, if the node is middle node, then link the next node to the previous node. And lastly is, if the node is end node, then remove the previous node link. And this is the code. And this is the output of the linked list before deletion and the linked list after deletion.
As the previous sister have been explained to us, this is the basic layout for the double list, which is in front we call it as head and at the end we call it as tail. The reason why we call it as double linked list because as we can see here, there is double pointer for each data. So for insertion, there is 4 examples to do the insertion in the double linked list, which is insertion at the front, insertion at the end, insertion before a node, and insertion after a node. So this is the example for insert a node at the front of which is the node that we want to place at the head, which is the head will be deleted first and will be placed by a new node, and the new node will be set to null as the new node is pointed to head. And after that, insert a node at the end, which is at the tail. So the next pointer of new node is actually a null. So if we insert a node at the end of the double linked list, it will be pointed in new null as the new node is placed at the tail. So as we can see here, this is the example of insert node before and after given node. So for example, if we want to enter a new node after node 2 and before node 3, the pointer here will be deleted, and the node 2 will be pointed to new node, and the new node will be pointed to node 3, as we can see here. In addition, the new node pointers are pointed to the old nodes correctly, as we can see here. And for deletion, there is only 3 examples, which is deletion of the first node, deletion of the last node, and deletion of node given the data. So this is the example of the deletion, which is we want to delete first the data at the B node So the pointer who pointed to B will be deleted, and B who pointed to C will be deleted also, which is after delete the pointer, BA will be pointed to C, which is the node after B, and the C will be pointed to A. And after that, B will be deleted from the list, which because A and C have been pointed to each other, and this is the final list of the data.
Okay, my name is Nabila Sahira Mita Zahendra, and I will present the circular recording for circular linked list. First one is function to insert nodes at the beginning of the list. So for entering data at the beginning of the linked list, we have to create a new node and assign the data to it. And when we add node at the beginning of the list, the next pointer of the last node points to the new node, and thereby making it a first node. Next one is function to insert nodes at the end of the list. It is almost same with just now, but entering data at the end is much easier than entering data at the beginning. The third one is function to insert nodes anywhere in between the beginning and at the end, which is the middle. So we just need to traverse the list and locate the node after which the new node is to be inserted. So we need to get the length of the list for making a decision to insert and to insert at the beginning or insert at the end. Okay, now we see function to the deletion part, which is to delete the node from the start of the list. So the process for deletion works almost in a similar manner as for insertion. Just now with only one fundamental difference, which is the deletion requires two pointers, one for pointing towards the node before and one for pointing towards the node after. This is the output that we will get, and we will, for example, this is the total data, which is 10, 20 and 30 that we will display after we enter data at the beginning, the end and the middle. So for the after we do the deletion part, which is remove from the end and remove from the start, this is the output that we will get. Okay, that's all for me.
I will tell about a theory of circular linked list. A circular linked list is a collection of nodes which the nodes are connected to each other to form a circle. So both singly linked list and doubly linked list can be made into a circular linked list. So the example of singly linked list is circular. This is the example of doubly linked list is circular. So I will tell the first operation of circular linked list, which is insert. So as you can see, B is the first element followed by C, D and E. So E as the last element we pointed to B. So if we add a new element in front of B, now B no longer the first element, but A is now the first element. So E as the last element we pointed to A. Next is the delete operation. As you can see, A is the first element, while E is the last element. If we delete E, A is no longer the last element, so D will taken the row as the last element. So D will pointed to A, which is the first element instead of E.